Hi kids, lights aren't on, trying to turn them on, probably not going to work very well. My goodness, I can't get this light on behind me. Okay, that's probably, okay, well, it's like I'm an amateur or something. I don't even know what I'm doing. You know what I'm missing. I forgot to have some coffee. Oh my God. Best free advertising ever. Haven't gotten a red cent from them. Just keep drinking their coffee. Whatever. Look who's here, kids. Mr. Key. What in the... Oh, there it is. Mr. Key. That would have been cool if I write and it all of a sudden just vanishes. All right, you guys ready? Ready to rock and roll, rollin' rocka. All right. You guys know our 6 trigonometric functions. Couldn't get that out. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Some old horse caught another horse taking oats away. Some old hippo caught another hippo tripping on alligators. And you know the rest. These are the reciprocal functions. So if sine is O over H, cosine, or cosecant is H over O, H over A, and A over O. Not too difficult. And while I'm here, let me remind you of something else that you learned the other day, and that was all students take calculus. Now, if you remember correctly, we learned this because in this one, all trig functions are positive. Everything, all things are positive. In this one, sine is positive. In this one, tangent is positive. In this one is cosine. Well, in this case, if sine is positive, then so is cosecant. And if tangent is positive, so is cotangent. And over here, if cosine is positive, so is secant. So remember, this tells you where those things are positive. Positive. Now, while I'm at it, could you tell me what this statement says? I didn't ask you to read it. I tell you to tell me what it means. Oh, well, what it's telling you. And what it's telling you is not x is greater than 0. What it's telling you is x is positive. I am tired of telling you all that. You must remember that. This means, or it says to you, x is negative. It's a huge thing on SATs. It's not really huge. It comes up like on one question. But if you remember it, it's kind of cool to remember. So don't forget it. All right, here we go. We're going to rock and roll. We're going to get through about half these problems in this video. Maybe I'll do the others in class. I'm not sure. Let me blow this up a little bit so you can read it. So this question is saying, given the values of sine, cosine, determine the quadrant. So we're going to try to figure out what quadrant, why using black there, theta lies in. What I should say is what quadrant the terminal side of theta lies in. That's probably not really worded very well. Maybe I'll change that when I print this. So what I'm telling you here is sine is negative. I don't care the fact that it's 1/4. I care that it's negative. Here, cosine is negative. So if I remember this, all students take calculus. And I come down here and I say, okay, I'm going to put little check marks where this is true. Where is this true? Well, all things are positive here, so I'm not going to put a check mark here. Sine is positive in this area, so I'm not going to put a check mark here. But sine is negative here, and cosine is, and sine is negative there. So sine is negative here, and sine is negative over here in the third and fourth quadrant. Then I'm going to use this information, and I'm going to put some check marks in. We'll do some check marks in blue. Cosine is negative in this quadrant and in this quadrant, because notice cosine's positive here and cosine's positive here. So it must be negative in the second and third quadrant. Wherever you put 2 check marks, that's the winner. So in this case, the answer is quadrant 3. Woo! When quadrant 3 comes up, I drink me some coffee. Because coffee done good for my brain. Ah, that's hot. No, not like that's hot. Good. That's hot. No, that's good. Wait, why am I just using sine and cosine? Oh, man, this isn't good. Anyway, I'll come back. At some other point, I'll use different cosecants and secants and all that crazy stuff. Oh, maybe I'll do that later. I do that later. Okay, so sine is positive and cosine is positive. So all students take calculus. Sine is positive here and here. Cosine is positive here because everything's positive here and here. Winner? Quadrant 1. Yay! Wow, those were difficult problems, kids. Let's move on. Now we're going to get into some tricky stuff. If sine of theta equals the square root of 2 over 2. Now that tells me that my reference angle, by now you should know, is 45 degrees. And we're in quadrant 1. Oh, well then not only that my reference angle, that is my actual angle. So what I want to do then is I want to draw a triangle in the first quadrant. Now the reason I draw it, I should draw my axes like this, with respect to the x-axis, is because always we want to talk about our theta in terms of being, we want to include the x-axis as one of our sides. You remember when we were doing reference angles and we were saying, okay, how close is it to the x-axis? That's what I want to be able to do. So I'll bring in theta. It's right here. And it said opposite square root of 2 over hypotenuse over 2. Opposite over hypotenuse. Well, if we know if it's a 45, 45, 90 right triangle, we know that to be an isosceles right triangle, which means these are both square roots of 2 over 2. So now I'm going to get my 6 trig functions, sine of theta, cosine of theta, tangent of theta, and I'm just going to do these 3. I know it says 6. It says what are the other 5. I'm going to start with this one, square root of 2 over 2. Cosine would also be the square root of 2 over 2. It's 45 degrees. And tangent is opposite. Let me highlight this. Opposite over adjacent. So tangent would be 1. Now I'm going to do the reciprocal functions. Cosecant theta, secant theta, and cotangent theta. Well, the reciprocal of 1 is 1. That's pretty easy. Now, the reciprocal of this is 2 over radical 2. But I can't leave it like that. I got to rationalize. So I'm going to multiply by radical 2 over radical 2. And this one gives me 2 radical 2 over... Now, when I multiply these two, I get radical 4, but that's just 2. These cancel, and I get the square root of 2. So if that's the square root of 2, so is that. Yay! Let's see. Let's try 6. I don't know why. Let's try 6. Okay. So here what I'm going to tell you is that 8 negative 15 is a point that is on the terminal side of theta. So what we need to do is draw our axes. And we need to find 8, negative 15. So 1, 2, 3, 4, 5, 6, 7, 8. I'm going to say it's right there. 8, negative 15. So basically what I have here is, if this is the terminal side of my angle really is right here. That's really my angle, because that's the terminal side. But that's not really going to help me out. I don't really want to use that one. I want to use the reference angle. So I'm going to call theta this. And I want to make a right triangle with it. So I'm going to use that point 815 or 8 negative 15 and make a right triangle with the x-axis. Always with the x-axis. And I remember that this was 8. and this was 15. So now what I'm going to do is I'm going to write sine theta. I'm going to get all 6 of them down there. The first one that was easy. This one's a little bit more tricky. So I'm going to get all 6 of them down there. Cosine. Oh, what am I doing? Cosecant theta. Secant theta. And cotangent theta. Now, I want to try to remember something. I'm going to try to remember that all students take calculus. So in this fourth quadrant, cosine is positive. So this is positive, and this is positive. Therefore, these must be all negative. So, as I'm doing these, I'm going to come up with a fraction for all of them, but sine and cosecant are negative, tangent and cotangent are negative. I'm going to put the negatives in there right now, so now I don't have to really worry about whether or not they're positive or negative. I know they're in the fourth quadrant, that those two are negative. I also have to find, by using the Pythagorean theorem, 8 squared plus 15 squared equals x squared. And I end up getting x squared equals 289, or x is equal to 17. Let me write that neater. 17. Okay, now I'm ready to go. Let me get a different pen out. Let's try black. So sine is opposite. Oh, I should label these. Opposite, adjacent, and hypotenuse. So sine is opposite over hypotenuse. 15 over 17. But since it's in the fourth quadrant, it's negative. And this is 17 over 15. Cosine is adjacent over hypotenuse, which is 8 over 17. And the reciprocal of that would be 17 over 8. And tangent is opposite over adjacent, which is 15 over 8. But again, since it's in the fourth quadrant, tangent's negative. We got the negative there. And 8 over 15. Yay! Done with that. Where are we going to? Let's go to number 7. I don't know why we're going to 7. Let's go to number 7. Okay, number 7. Basically, we're going to do the same kind of thing. Draw our axes in. Negative 7, negative 2. So here we go. Negative 7, about here. Negative 2, about here. So I know that's on the terminal side of my angle. I normally would use this as theta, but again, not 0, but theta. But again, since I don't want to use that whole angle, I'm just going to use the reference angle, so I can use this reference triangle, make my life easier. So, we know this is 7, and we know this is 2. I still got to find the hypotenuse, so let's do 2 squared plus 7 squared equals x squared. X squared equals, let's see, that's 49 plus 4, which is 53, or x is equal to the square root of 53. And I believe 53 is prime, so this is just equal to the square root of 53. So this is going to be a little bit tricky. Let's get them all down there. Sine of theta, cosine of theta, tangent of theta, cosecant of theta. Even I, once in a while, want to write secant with sine, but it's not. Remember, we math teachers hate you. We confuse you. And cotangent of theta. Now I'm going to come through and put my signs in. Now wait a second. All students take tangents positive. This is going to be the positive one, and this is going to be the positive one. That means these are negative. Negative, 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 and negative. Right? Because the only thing that's going to be positive down here is cotangent and tangent. All right. Now I'm ready to go. Sine is 2 over radical 53. Oh, crap. Cosecant is radical 53 over 2. Cosine is 7 over radical 53. Remember, it's negative. And negative radical 53 over 7. This one's not bad. Opposite over adjacent is just 2 over 7 or 7 over 2. These two are problems because we can't leave radicals in the denominator. So I'm going to bring, I don't care about the negative right now, I'm going to bring this 2 radical 53 over here, and I'm going to multiply by radical 53 over radical 53. You guys like the way I say radical, don't you? So I get 2 radical 53 over, and then when I multiply these two together, I just get 53. So this isn't quite the right answer. Boy, my eraser just went nuts. So this is negative 2 radical 53 over 53. And then this one's going to be negative 7 radical 53 over 53. So there's your answers. Kind of messy. Sorry about that. I'm going to try and neaten it up a little bit next time. Maybe. Maybe I don't like you. Maybe I won't. Let's go to the next one. Okay, you still got to figure out what quadrant you're in. I didn't give you a point, but I did tell you that cosine is positive. Right here, positive. And tangent is negative. Let's see. Where is cosine positive? All students take calculus. So cosine's positive here and here. Tangent is negative here and up here. So we're looking at the fourth quadrant. So I want to draw a triangle in the fourth quadrant. And I gave it as the square root of 2 over 2. And I did this one hoping that you memorize it. Oh yeah, that's that 45, 45, 90 right triangle. Ow! Ow, 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 ow. I just ganked my leg. That hurted. Anyway, all right, let's go through this then. Sine theta, cosine theta, tangent theta. I'm going to leave a little room this time. You'll see why in a minute. Cosecant theta, secant theta, and cotangent theta. All right, now I need to figure out where things are going to be negative. Well, I know cosine's positive, and so therefore is secant. And we're in the fourth quadrant, and all students take calculus. Down here, only cosine's positive, so this is going to be negative. This is going to be negative. This will be positive, and this will be positive, and this will be negative, and this will be negative. All right. So I know cosine is the square root of 2 over 2. Sine is also the square root of 2 over 2. Tangent is the square root of 2 over the square root of 2, which is just 1. And if you take the reciprocal of 1, in this case negative 1, you still get negative 1. Now, in order to get to here, I got to take the reciprocal of the square root of 2 over 2. Now, we've already done this a couple times. I hope by now you just know what that is. But we're going to multiply by radical 2. Oh, first thing we're going to do is take the reciprocal of it, which is 2 over radical 2. And then you're going to multiply by radical 2 over radical 2. Because remember, this is 2 over radical 2. It's negative, I know, but we got to rationalize it. So I get 2 radical 2 over 2, and those cancel. So really what I end up with here is negative radical 2. And over here what I end up with is just positive radical 2. There we go, kids. That one's done. What number was that? That was 8? That was 8. Let's go off to 10. One more. Now in class, by now, I'm going to stop and I'm going to have you guys try these on your own. So, if you're watching this video and you're just regurgitating my notes, you probably ought to pause right now and try this one on your own. I've done enough of these now that you should be able to figure out some things on your own. This one's a little tricky, but you can try it. So hit pause now while I drink coffee. No, you gotta hit the pause button. Otherwise, you're gonna watch me drink coffee. Hit the pause button. You still got to watch me drink coffee. Anyway, here we go. First thing I want to do is figure out what quadrant I'm going to do it kind of small here. All students take calculus. This, oh wait, I don't know anything about secant. Let's see, secant goes with cosine. So cosine is negative. I don't care about the 5/4 right now. I know cosine is negative. So I need to figure out which quadrants cosine is negative. Cosine is negative here and here. Sine, remember this doesn't mean greater than 0, it means positive. Sine is positive here. So I don't even have to go positive here and here. I don't have to go any further. I'm in quadrant 2. So I'm going to draw my triangle in quadrant 2. Don't really care what it looks like. Now, the only real numbers piece of information I was given was that, let's put it right here, secant theta, probably need the C, secant theta is equal to -5/4. Well, I think if I'm smart, I can work backwards this way and say, okay, that means cosine theta is equal to -4/5. Now, why is that useful? Well, I know that cosine, some old horse caught another horse, is adjacent over hypotenuse. So what I'm going to do is come back to my drawing here, my theta, and I'm going to say, okay, adjacent 4/5. Now, I don't really want to put the negative in there because negative indicates either direction, and I could put the negative in here because we are going to the left, but it usually represents magnitude as well, you know. Well, magnitude represents direction, and so I just want to know its distance, or its length. Magnitude has, you'll learn it in physics, but also has direction with it as well. So 4 here, and 5 would be my hypotenuse, adjacent over hypotenuse. And I think most of you are smart enough to realize then that this is 3. All right, so I'm going to sine of theta and cosecant theta. Those are the positive ones. And tangent of theta in this quadrant is negative, so I'm going to put it in there. And cotangent theta is also negative in there, so I'll put that in there. Sine is 3/5, and we know it's positive, 3/5. So this is 5/3. Tangent is 3/4, but we know it's negative. We already got the negative there, 3/4 and 4/3. The big thing that most kids are going to forget are those signs. So really get those signs in there early and really start thinking about what those signs mean. All right, we're going to go to 12 next. Oh, 12. 12. What do I want to do 12? Oh. Find the exact value of cosecant, secant, and cotangent. Let's see what quadrant we're in. -1, -1. I'm in the 4th quadrant. Let me put my lengths in there. 1 and 1, and I got to figure out what that is. I know this is a 45 right triangle. So let's see. 1 squared plus 1 squared equals x squared, or x squared equals 2, or x is equal to the square root of 2. Kind of knew that. We should have known that. We've already done it a bunch of times, square root of 2. So, oh gosh. You know, I only want these 3, but in order to figure out cosecant, I really need to know sine. So let's see. Sine would be opposite 1, so sine is 1/radical 2. So cosecant theta is radical 2/1, which is just radical 2. But all students take calculus, only tangent and cotangent are going to be positive in this quadrant. So I also know this is negative radical 2. Now I'm going to do secant theta. Well, secant is the reciprocal of cosine, and cosine is also 1 over radical 2. 1 over radical 2. So if I flip that, I get radical 2 over 1, or just radical 2, but it's also negative in that quadrant. And cotangent then would just be 1 over 1, which is just 1. It's positive in that quadrant. We're good. There we go. All right, moving on, kids. Next problem I want to do is 19. I'm going to turn the page. You're going to come down here. Those you should be able to figure out. What is this? Let's see. What do we got here? Unit circle. There's that square root of 3 over 2, and there's that 1/2. That means a lot to me. And it's on the unit circle. So let me draw the unit circle. Let me try to remember the unit circle. This is the unit circle. Draw that unit circle in. And my answer key is wrong. And both of these are negative, negative and negative. That means I'm in the third quadrant. Need to draw a triangle in the third quadrant. And, well, wait a second. If we're on the unit circle, we talked about the unit circle. This distance here was 1. And if I draw my triangle in, this x value, which is the square root of 3 over 2, and this y value, which is 1/2. If we remember correctly, this represents the cosine of theta, and this represents the sine of theta. Opposite over hypotenuse, 1/2 over 1. This is 1/2 over 1, opposite. Here's my angle. This would be the square root of 3 over 2 all over 1, but really you don't need this 1, right? So I know that the cosine of theta is negative square root of 3 over 2. And the sine of theta is negative 1/2. Well, that makes this negative 2. Now I got to take the reciprocal of this for secant, but we'll come back to that. Oh, tangent. Tangent's kind of a pain too. So we'll do that. Let's do the reciprocal of this. So 2 over radical 3. Notice I'm not really worried about the sign now because I already know this is negative. I'm going to multiply by radical 3 over radical 3. And I get 2 radical 3 over 3. There it is. Negative 2 radical 3 over 3. And this last one's kind of tricky. You have to do opposite over hypotenuse. You either have to memorize what tangent is, and this is, by the way, you should recognize this is a 30-degree reference angle, right? You should represent, because we're coming out more than we're going down, you represent this as a 30-degree reference angle. So if you know the tangent of 30 degrees is the square root of 3 over 3, you can just stop right there. Or you can do opposite, which is 1/2, over adjacent, which is radical 3 over 2. Now what we're going to do is we're going to end up multiplying by the reciprocal. So we're going to take this, remember we're dividing, so we're going to multiply by its reciprocal, which is 2 over radical 3. Well, what I end up with is 2 over 2 radical 3. These 2's cancel, but I'll do it in a minute. Multiply by radical 3 over radical 3. So let's see, these 2's cancel. And I end up with radical 3 all over 3. So this is radical 3 over 3. And hopefully by now you remember that the reciprocal of this is just radical 3. So there's that. Of course, my answer key is completely wrong. That's embarrassing. I'll have to redo an answer key for that. I think I wanted to end there, but I want to talk a little bit about this over here with you. I want you to think about what these reference angles mean. where I would draw this here, and I would say, okay, I'm in the, see, we're on the unit circle, remember? We're on the unit circle. So let me highlight that. Unit circle. And because it's the unit circle, the x value represents cosine, and the y value represents sine of theta. Now, when cosine is the square root of 3 over 2 and sine is 1/2, this is a 30-degree angle. I got to know that one. I know the cosine of 30 is the square root of 3 over 2. The sine of 30 is 1/2. I got to know that. I don't care about the sines right now. Now I'm going to worry about the sines. Cosine is negative. That's in these two quadrants. And sine is positive. That means I'm in this quadrant. So here's my 30-degree reference angle. Okay. If that's 30 degrees, this is the actual angle measure right here. There's theta. And that would be 150 degrees. Let me do one more for you. I'll just do this one. Nah, we'll do this one. No, that was too easy. Well, let me do one example for you. What if I did negative radical 2 over 2 and radical 2 over 2? Let's change that. Let's make this negative and this positive, just for fun. So I think, okay, this is cosine. Now I know this is 45 degrees. As soon as I see radical 2 over 2, I know it's 45 degrees. Both cosine and sine are the same thing. I just got to figure out which quadrant I'm in. So cosine is positive. Ka-ching, ka-ching. Sine is negative. Ba-ching. I'm in this quadrant right here. So this is 45 degrees. So what does that make this? That makes this 315-degree angle. All right, so you guys got to finish those for homework. That's your job. Good luck with it. And I'll see you on the flip side, kiddies. Bye.